How do you go from being a technological laughingstock to, well, planning missions to Mars? Today, we are unpacking the epic, century-long story of America's space agency. It's a journey that was really fueled by humiliation, intense rivalry, and this relentless drive for discovery.
Okay, so to really get this, we have to rewind all the way back to World War I. Now, you have to remember, the airplane was an American invention, but when war broke out, the U.S. military had, get this, only 23 aircraft. I mean, compare that to France's 1,400. This wasn't just a small gap in technology, it was a huge national embarrassment. And that feeling, right there, that became the rocket fuel for everything that followed.
So that feeling of being so far behind in the air, it spurred immediate action. The U.S. government knew it needed a dedicated organization just to catch up. And that led to the creation of NASA's direct predecessor and, in a lot of ways, its father.
That organization was NACA, and its mission was crystal clear, and let me tell you, it had absolutely nothing to do with space. Its one and only job was to understand and completely master the technology of flight, just to make sure America would never ever be left behind in the air again.
And you want to know how big this grand ambition started? NACA was launched with a budget of just $5,000. That's it, a laughably small sum that was supposed to challenge the world's aviation giants. But hey, it was a start.
And wow, what a start it was. Over the next few decades, NACA was just incredibly successful. By the time World War II ended, the U.S. had completely transformed its air power from this point of embarrassment to, well, absolute global dominance. We're talking more than 300,000 military aircraft, more than any other country on the entire planet.
But you know, just as America had conquered the skies, a brand new frontier opened up. A new challenge emerged from way beyond the atmosphere, and the game was about to change completely.
That change arrived as a tiny, beeping satellite. When the Soviet Union launched Sputnik 1 right at the height of the Cold War, the fear in America wasn't really about the satellite itself. No, it was about the massive R-7 rocket that put it up there, an intercontinental ballistic missile that was powerful enough to carry a nuclear warhead straight to American soil.
The American response was, well, immediate. The government didn't just start a new agency from scratch, it completely transformed the one it already had. The aeronautical engineers, the wind tunnels, pretty much the entire brain trust of NACA became the foundation for the brand new National Aeronautics and Space Administration, NASA. And with that came a seismic shift in funding. I mean, think about it, from $5,000 to master the sky to $58 million to go out and conquer the stars.
And this is what really ignited the space race. The U.S. scrambled to launch its own satellite, Explorer 1, but then, in 1961, the Soviets delivered another just stunning blow. They put Yuri Gagarin into orbit, the first human being in space. And just like that, once again, America was playing catch-up.
Faced with this new sense of urgency, the United States didn't just aim to catch up this time. It set its sights on a goal so audacious, so seemingly impossible, that it would come to define an entire generation. Landing a human being on the moon. The Apollo program was this incredible high-stakes climb. It started with the insanely daring Apollo 8 mission, which sent the first humans to ever leave Earth's orbit and actually circle the moon. That was a huge gamble, but it proved the technology could work. That flight paved the way for Apollo 11's historic landing, and eventually 12 astronauts would walk on the moon before the program's astronomical costs finally brought it to an end.
Neil Armstrong's iconic words, of course, captured that moment that humanity officially became an interplanetary species. He and Buzz Aldrin spent over 21 hours on the surface, setting up experiments, grabbing lunar samples, all while Michael Collins kept their ride home, the command module, circling in orbit right above them.
But victory in space was never, ever guaranteed. The near tragedy of Apollo 13, that became its own kind of legend. An oxygen tank explosion crippled their spacecraft hundreds of thousands of miles from home. It sparked this desperate, real-time race against the clock. It's a story of just breathtaking ingenuity, where teams on the ground were inventing solutions on the fly to bring that crew back alive. So that successful failure of Apollo 13, plus the staggering cost of winning the moon race, well, it marked a turning point. The era of blank checks and human spectacle was pretty much over. NASA's focus pivoted towards something more sustainable: science, cost-effectiveness, and a new generation of tireless robotic explorers that could go farther and stay longer than any human ever could. And you can see this new philosophy perfectly in the evolution of our robotic ambassadors on Mars. From the pioneering Pathfinder back in '97 to the marathon missions of Spirit and Opportunity, each rover just got more and more capable. Curiosity uncovered definitive proof of ancient water, and then Perseverance actually took flight, deploying a helicopter drone named Ingenuity in the thin Martian air. Just incredible. And this new era was just packed with these foundational achievements that totally redefined our place in the cosmos. Skylab was America's first lab in orbit, and it taught us how to live in space. The Voyager probes became humanity's first interstellar messengers. The reusable space shuttle was the workhorse that made routine trips to orbit possible, letting us build incredible tools like the Hubble Space Telescope, and, in a real triumph of global cooperation, the International Space Station.
And to really wrap your head around the Voyager missions, think about this. They are hurtling away from us at 17 kilometers every single second. As the most distant human-made objects ever, they're still out there, continuing their silent journey, carrying a golden record of Earth's sights and sounds into the vast cosmic dark.
Which, well, brings us to today. After a pause of more than 50 years in human deep space exploration, NASA is looking back to the moon, but not as a final destination. This time, it's a crucial stepping stone for what comes next. The new Artemis program is a direct echo of that golden age. In fact, the upcoming Artemis 2 mission is designed to do exactly what Apollo 8 did all those years ago, send a human crew on a flight around the moon. The big difference this time? 50 years of accumulated knowledge and technological advancement.
So why are we going back? Well, this time, the mission isn't just to plant a flag and come home. The whole goal of Artemis is to establish a sustainable, long-term human outpost on the moon. It's meant to be a proving ground, a deep space workshop, and the launch pad for humanity's next giant leap, sending astronauts to Mars.
And this renewed ambition is being powered by a new generation of incredible instruments. After more than 20 years of development, the James Webb Space Telescope was finally launched in 2021, and it is already, right now, revolutionizing our understanding of the earliest moments of the universe.
So we end right where we began, with a challenge. From a humiliating 23 airplanes and a $5,000 budget to sophisticated rovers and multi-billion-dollar plans for Mars, this journey really shows what's possible when ambition meets ingenuity. And it leaves us with just one question. If this is what we did in the last century, what will the next 100 years of exploration bring?